start. Audio. I will check. Thank you. I removed the other microphone because I have two. So is it okay now?
Yes, sir. Thank you, sir.
Yes, sir.
Thank you, sir.
Okay, so last time we start with this topic, but we haven't yet give more emphasis on this. So we will move forward to discuss it again. As an example, for example, in a subnet mask, we have this subnet mask 255.255.0.0. This was the binary math. So how many bits do you have here? So you have 8 bit and you have another 8 bit. So in this case, this would be your class B. But for example, we have another example from this. So what type of address is this? Class A, Class B, or Class C? This address.
A, sir.
So this address is Class A. So it's more on a public network, private network or companies, because they have a lot of host bit. Now, for example, the subnet mask given for this Class A is 255.0.0.0. Because the first octet of the subnet mask is 255, so we refer to this as 255, and the next one would be 0 in this case for this example. Now for your network ID, that is 10. So this is 10. This is in decimal, so you don't need to read this in binary as 10, but this one is 10. That is your network ID, and the host ID is on the last part, the last consecutive numbers. So these are your host ID. So this is your network ID for this example. But however, the network ID and host ID are used together when configuring computer IP address and when communicating with one another. So the source address in a network packet being sent is 10.1.221.101. So that is your source address. Now, for the two cases when the two octet, this one is this one is what type of IP address is this? When you have 172.31,
Class B, sir.
so this is class B, correct? And it's one of the contiguous network in which the packet and are sent between every pair of subnet pass through the subnet of the same network. So the network ID is this is your network ID for class B. And for your host ID, that is 10.100.6. So when referring to the network ID, you should always fill in those host part of the address with zeros. So, for example, if you are given this question, so the answer would be network ID should be 172.31.0.0. So that is your network ID given the following question. And the host ID is the last contiguous address of your Class B IP address. Okay, so move to the second. So we have example. This one is Class C. So most of the time I use this in a small office or small businesses because it is requires only lesser ports, and you will use only like maybe 3 departments or 2. So we use Class C addressing most of the time, and the network ID is identified on the first 3 octets. So this one, and this one. So how many bits if we considered the 3 octets? How many bits? So this is 8 bit, and you have this one is another 8. So you have overall you have 24 bits. And that's why in your subnet mask, automatically it would register at 255.255.255, which implies also the location of your IP address that it contains this the following. So what is left for you is you have dot zero. So meaning the maximum number are on this side, 256, 0 to 256, and the last part would be 255. So overall you have 255 host ID for IP address Class C. And you cannot have this example because the network ID must be contiguous because you're considered Class C, and once you have this is an invalid subnet mask because you need to fill in all the 8 bits. So this is 8 bit, and this is 8 bit, and this is 8 bit. So in this case, this written example is invalid because it would not allow the devices to communicate because the address is not the same as not the same classes, so it would not uh, be configured. But in some cases, so you could have this subnet mask 172.16.67.5, and also you could have 255.255.192.0. And what's going on in the third octet in this subnet mask, even though this subnet mask doesn't look like the other examples, we only the values of 255 and 0. It's still a contiguous series of ones followed by a contiguous series of 0. So it means the subnet mask look like this. So this one, the subnet mask is equivalent to this subnet mask. So this is 192, and this is 255, and this 255. So this having a contiguous series of ones and zero, but this one is not allowed. Now, how do we calculate in binary? So, as we remember, if we have the same input in logic AND, so you will have an output. But in cases in both scenarios that the input A and input B are not equal, so it would not be equal to 1, but all of it would be 0. In either case, if 1 and 0 is 0 still, 0 and 1, that would be still 0, and 1 and 1, that would be 1. So that's how you calculate for the logic AND. And because to determine the network ID that is based on IP address, okay, we finish. Uh, and subnet mask, the computer simply performs logical AND between the binary digits in the IP address and the binary digits in the subnet mask. So this is your network ID example. And your subnet mask is this one. So how do you determine the network ID? So you perform logic AND. So how do we perform logic AND? So okay. So we perform logic AND. So each digit will be compared. Okay, 0 and 0. 0 and 0 is
0, sir.
so you have 0. So in any case, in logic AND, so if we go back, so 1 and 0 will be still 0. So in this case, so it's going to be the same. So this one, 1 and 0 is still 0. So all of it until here will be also be 0. And when you go back here, so what will be the value? So that is with this directly, you will have also all of it will become 0. So that's why you have this network ID. Using AND value, you could determine the network ID. And for this, we perform also logic AND on the same values. So this one is 1 and this one 0. So it's likely we have the result of your network ID. So that's how we determine the network ID in your given. So for example, if you take the binary digit from the IP address, so as previous, so for example, this is the network ID that we have, and we use a different subnet mask. So this one is the network ID. So example, for the second one, so it would be different. So for example, we have 172.16.67. So what will happen? So given the subnet mask and the IP address, so you will compute. So with this number, all of this will become 0 as compared by AND logic. And showing the values on this side, this would be correct 1 because you have both 1, you will have 1. But 0 and 1 is 0, so that is also correct. And this one, 1 and 0 is 0. So the result value for this is, so you have 172.16.64. So that is your network ID for a given example. This is a second example. So after the result, you will have the network ID 172.16. Now, what happened to the other bits that we have? So since we have 67 and this, so we have uh, 7 minus 4. So you have 4 bits. I mean 3 bits from 0 to 3. That would be 4. This one is 0 to 6, 0 to 5. That is 6. So you have 10 bits total. But the value are separated by each most significant bit, and this is your least significant bit. So on this side, so you have 5 and 3 and 3.5, 3.5, what is left. So the remaining bits in the IP address aren't part of the network ID, but are part of the host ID. So in this case, it's this one is being subtracted to 67. So this is your network ID, and this part are for your host ID. So essentially, anywhere there's a 1 bit in the subnet mask, its corresponding bits in the IP address are part of the network ID. And anywhere there's a 0 bits in the subnet mask, it's corresponding to be part of the host ID. So that is about host ID and network ID. Now for converting, so make sure that you have background on this because we need a lot of conversion with binary and decimal. And you should start counting from 0 because we are not counting starting from 1 here in the computer. So the first number that you will count is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, or in binary, 0 and 1, 1, 0. So that's how you count in binary. And for conversion, again, so I think we finished on this last time. And you have also logic circuit, right? Subject logic circuit. You have subject logic circuit.
Wala, sir.
But during your third year, you will have it, maybe second semester. I don't know. It's maybe me who's going to be a professor. Okay, so we finish on this. Now, this one, what we call. Take note always, in subnetting, we use classless interdomain routing CIDR system. So if you encounter this, mostly, example, even if we don't touch up on CIDR, but on the previous example, I will let you know how to identify CIDR. So we have, for example, every classes, we will identify CIDR. Okay, for this class, what is the CIDR for this class? For class A. So how many are being seen in network ID? What is the network ID of class A? This is
10.
the 10 dot
10,
10
sir.
dot 10 dot 0 dot 0 dot 0 dot 0. So the subnet mask is 255. So the CIDR is how many bits for this? For class A, how many bits we consider?
32, sir.
What? How many bits?
24. 24.
In example, subnet mask. This is 1, 2, 3, 8.
8, sir.
8, sir.
So
8.
we have only 8, okay? In class A. That is your CIDR notation. If you're going to write it in CIDR notation, so you need to check your subnet mask and your network ID. So if your network ID is only on the first octet, so meaning your CIDR is only 8 bit. Okay. So we go now for class B. Now for class B, so we have two octets. So what is a CIDR? If we have two octet, first octet, second octet, so you have the same one.
16.
Sir.
Okay, okay, 16. So you have 16. Okay, that's for class. Where is this? So 16. Okay, so take note every subnet mask. So you have 8 bit, 8 bit. So in this case, the CIDR notation. If I'm going to write the CIDR notation for the IP address, that is slash 16. That's for your class B. Now for your class C, so this is now your how much is the CIDR? So you have 8 plus 8 plus 8. So
24, sir.
your CIDR for this is 24. So now we both know the CDR notation as we go with the summary. So later we have the summary of the lecture. So we identify the CIDR. It's really going to help us in identifying what classes IP address that we are handling. Okay, so any more information on this? So nothing new. Okay, for IP version 6, uh, since IP version 4 uses how many bits? IP version 4. How many bits we are using?
8, sir.
It's 32.
32.
So instead of 32 bits used by IP version for addressing, so nowadays we have IP version 6. Since we have only limited amount of IP address to handle in the companies and other private institutions. So that's why they implemented a private IP address. But to solve this problem, due to the emergence of technology and there are more computers, more machines use IP address. So because IP address is a unique number that is going to be, it's like your ID on your personal ID. So the bigger population is the more IP address that you require. So like in Philippines, so we could not accommodate all people with one IP address. But to solve this problem, they implemented IP version 6. But IP version 6 is long offers a long-term solution, and the emergence of IP version 6 also will have different approach in instead of using octet, IP address version 6 use hexadecimal values. So that's why it's more on 16-bit. So 16-bit. So every notation here is implemented by 16-bit. So and usually it is represented by 8 groups. And why is it there are some numbers that are 100, 100 hex? Because in hexadecimal class, where's my, here, okay. In hexadecimal, so in hexadecimal, this is still 16-bit, but 0 is the most significant bit. So 0 is not counted as a number. But when you read this is 100 hex. At the same time, the same with this 162. So this is 0162, but when you write it, it's going to be just 162 hex. And uh, this is what they mean as 4 hexadecimal digits. So after 0 to 9, what is the next value for hexadecimal? Diba hexadecimal is from 0 to F? Have you discussed hexadecimal? Hexadecimal value. When you count from 0 to 9, then after 0 to 9, you don't have 10, but you have A. A. A is 10 in hexadecimal, then is going to F. So in that case, that's hexadecimal. I'm just going to explain hexadecimal, but in your logic circuit, maybe next semester you have this specifically. But we will not focus more on hexadecimal here, but more on the IP version 4, which is being used nowadays in some companies. Now, to identify your IP version 6, so you go to test ipv6.com, and what will happen is you have to identify your IP address on the public internet. So this is my IP address, and also your internet service provider will appear also, and your uh, DNS. So I make my DNS automatic, so it's not going to appear. So the class A started from 1 to 1 and 27. And that's why class A is intended for large corporations, and usually assigns at the first octet and leaving the last 3 octets for the network administrator. So this allows 24 bits of address space, and the capacity of class A is about 16 million hosts. So you could host about 16 million in network address. So example in 10.0.0.0, so you could host a lot of people there, and in and the last address would be 10.255.255.254. And for class B, that is from 128 to 191. So which is intended for, and the following notes that you're going to try to check whether it's class A or class B is this one. If you see these numbers between 1 and A, that is class A. If you see a number between 128 and 191, and that is class B. So, and the host, you could allow only 65,000 hosts. And this one is about 16 million hosts per network for class A. Now, for class C, so it's intended for small network. The IP address is assigned to the first octet, ranging from 192 to 223. So this one is class C. We have 203.1.1.3, 3.1.254, for example. So the IP address for this value is we have this one. So class C is limited only for 254 host network. Why we are using class C in our system? In CAMC, we use class C, I think. And also our IP address of CAMC is closely on this number, 203. And on your, I think on your test, I put, on the online test, I put the IP address of CAMC, that is 203 Kahoot, I think. So that's for class A, class B, and class C. And for class D, so is reserved for multicasting for video conferencing and streaming media. So this class D have different application, and also for class C, they have a different range of the first octet, and for the class D, so you have also different. You will take notes all of this. This would identify what network are you into. Now for a summary for IP addressing. So the first value of the first octet for class A is 0 to 127, and for class B you have 128 to 191. For class C you have 192 to 223. For your subnet mask, you will start at 255.0.0.0. For class B, you have 255.255.0.0, and for your class C, so you have these values, and the number of network ID bits in class A is 8-bit. For your class B, that is 16. For your class C, that is 32. And the maximum number of hosts per network, that would be higher in A, and it's getting lower to class C. So why do you think class C have a lesser number of hosts for network? Why do you
Yung
think
8 lang ang
class C?
bytes na.
So because you have only to use 8 host bits, and 254 number of hosts is already too much for one example. You have only one coffee shop, right? So no, your number of guests would not exceed to 200. So that's why sometimes when you are in the conference in some hotel, you could not enter to the Wi-Fi internet because there are only limited number of hosts that they allow. So example, there are like 200 people or guests, and there's also another host that you're going to use. So this one is basically applicable to small gathering or small businesses. But if you are like using IP address for machine, it's better to have class B. Or if you are a big university that you have a lot of resources, so you use class A. Or in the future, possibly we could adopt more IP addresses if we going to migrate to uh, more applications on our computer. But now, since we use it mostly in the offices, so it's not really that big. And the calculation for the number of hosts is, example, you have 2 to the n minus 2. So n is the number of bits in the host ID. So for class C, how many are the host bit? So you have 8, diba? 8. So when you solve the number of hosts, so you have example, let's say in the 8 value in the host ID, so you have 4, so minus 2. So how much is your number of hosts? Number of hosts that you could use for this example. 2 to the 4 minus 2 is how much? 2 times 2, 4 times 2, 8. 8 times 2.
10, sir.
So you have 16. 16 minus 2, that is, you have, is it correct? 14? Because you're going to subtract it by 2. So this is 16 minus 2. So you have 14 hosts. So you will have 14 addresses that will be used. This is only for small local area network. And example, you have 6 bits in the host ID. So how do we put bits in a 6-bit? Example, the maximum is, this is 8-bit maximum. So 1, 2, 3, 4, 5, 6, 7, 8. So this is in binary. So what is the maximum value for this? This is equal again to 2, 5,
5,
5.
5.
Okay. So if you have only a small local area network, example, you have only, so let's say this one, what is 4? So 4 is 1, 2, 4, 8. So you have 0, 1, 0, 0, So this is in binary, but your address will be like for this example that I give. So example we have 255, and you subtract 4 into 55. That is how much?
251.
So you have 250. Okay, 251 or 250 because you have 1 bit left. So your values would be 250, or if you start at 0, so it would be 251. So 0 is taken, 1, 2, uh, 3, 4. So what is left is 2. So you have 250. And the maximum value here, as we mentioned earlier, is 254. So if we deduct 4 bits, so this would be 250. Because class, we started our count at 0. Okay? So the maximum value here is 250. Okay, so sorry, 254. But we have a 4-bit host. So the value would be uh, 4, and minus is you have 250. So here is the decimal value, and this is the. But if you want to work on the other side, so this is 255 dot 255. So let's say we have a 0, or we have this is 0 to 250. So there are a lot of host number. But on the case that you only need 4-bit, so we have 255. So 255. So we have 254. So which one is easier to configure? This one, 0 to 250, or 250 to 254, which is have the same 4-bit scenario. So 250 to 254 is much easier compared to 0 to 250 because you have so many hosts here, and all you need is only 4-bit of your subnet mask. So that's the difference why we focus more on this side. And this one, just a takeaway, just for additional readings. So normally, why we have too few IPv4? Because IPv4 was implemented before it was last decade, maybe 2010, and now still we are still using it because it's difficult to migrate to IPv6. We need equipment, and we need to have our internet infrastructure that is really good. And also, it would be expensive on the part of some government. Uh, uh, but if you have a company, mostly they use IPv6. And uh, Class A usually begins at 10, and Class B usually start at 172, and Class C usually we have 192.168.0, and these ranges are what we call the network address translation, or NAT. And the private IP address, it's the address that your network router assigns to your device. Each device within the same network is assigned to a unique private IP address. So as you can see, what is the difference? So let's say you have here at your home. So each device that you connect will have a different IP address, but it's connected to your, what is this symbol? This is your home
Home router,
router.
sir.
Yes, home router, correct?
Router.
Okay, thank you. So you play iPad, you play your phone, you use your laptop, you use your monitor to type, to listen to the lecture. And another type of private IP address is a linked local address. Usually, we have this term, dynamic host configuration protocol. It usually, if you press assign automatically, as we know in the previous lecture, we have this. Now, if you put obtain an IP address automatically, it would just be vacant here, di ba? So you could not write anything if you select obtain IP address automatically. So, and also it would be default. So the computer will generate its own IP address using DHCP, your dynamic host configuration protocol. So it would configure the IP address uh, in your computer or in your mobile device. Also, we have another term for this IP address is that is assigned for only for 169.254.1.0 through 169.254.254.255, and that is your APIPA, or your automatic private IP address. And take note, we have always this notation. Just like what we did earlier, we make a notation for every class A, class B, class C. But in this scenario, this is your first octet, second octet, third octet, and fourth octet. And this is your CIDR notation, is the number of bits in the subnet mask. So for class A, how many bits do you have for your subnet mask? That is 8-bit, and for your class B, you have 16, and for your class C, you have 24. So this is just like a prefix you always see on some books. Now, for example, we have this number 172.31.210.10. So how do we express this? So we can express this as 172.31.210.10 slash 224. Now, this value depends on your subnet mask. Okay? So if your subnet mask is 255.255.255, so definitely you have 8. This one is 8-bit, 8-bit, and 8-bit. So adding it up is you have your network ID that is 24 bits given the subnet mask. Okay? And you have what is left for your host ID is your this is your 8-bit host ID. So that's how we have to write in CIDR domain. Okay. Now, for example, we have a different IP address with a subnet mask of this one. And how do we know that we have 20? How do we know that we have 20 bit? So first, in order for us to know the bits that we have is to convert this into what? How do we convert this? How do we convert to 40? So by using decimal to you convert this to decimal to binary. What is the equivalent of decimal to binary for this example? For 240, who can convert now?
Sir. One 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 zero 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 zero, sir. Excuse me, sir. Wala ka audio, sir.
Sorry. Okay, so earlier, as we discussed, so the number of ones bit is always your network ID. That would determine the number of your network ID. Now, how do we compute for the 12-bit? Normally, we just going to count the number of zeros in the host ID. So how many zeros do we have in the host ID? Starting from your least significant bit. So here 1. So these are 8. 8 plus 8 plus 4, that is your 12 bit host ID. And this is your network ID. So this is your 20 bit network ID. So first, you need to convert this into uh, decimal, to binary, and it will determine the number of host bit and your network ID. So that's how also we determine our notation that we're going to put on our network ID. So in the host ID, so we will assign who will be host 1, host 2, host 3, and that's it for the classless interdomain routing. Now for the broadcast domain, so yeah, it defines which devices must receive a packet that is broadcast by another device to each port on a router, and constitute a broadcast domain because routers don't forward broadcast packets. Only TCP/IP communication relies on heavily on broadcast packets to perform variety of functions. And as we know, the HCP and ARP used broadcast ID to perform their task. So every time a broadcast packet like the network interface card, it generates an interrupt causing the CPU to stop, and it's going to read the packet. If the broadcast is not really important to the computer, the packet will be disregarded. Now we could imagine if we have, for example, 6,500 computers. So what class can handle this number? So we are expecting what class of IP address? Host per network. So we have
A,
class
sir.
class B. But class B, it's limited. But if you want to maximize it, but if you go higher to the class A, it might be expensive because of the number of hosts are more. So in both cases, you could have class A and class B for this scenario. Two would be good, right? So on this side, you will see if you have 6,500 computers, so you could be able to use class A, class B, but for class C, you only have a small number of hosts per network. So in cases, that's why when I, for example, register you in Kahoot, if I will allow like 1,000 students to enter in the Kahoot, I will pay more. I will have class B or class B IP address that will be assigned to each student. But if I only have a class C, it would be cheaper. So that would be dependent on the number of hosts that you will be having. And we are done with this. Hopefully you could answer your test until tomorrow, because I know some of you, I read some of the answers. You could still, if you want to, eh, uh, if you want to improve your score, I will have one chance retest if you want to erase your result and retake again. Also, do not just take it like easy. You make good at it so that your grade will be okay also. So if you want to erase your previous result in your test 03, you could ask me to erase your result and you can retake again the test if you want. So I don't, yes, any question?
Saan nun available ang retake, sir?
I-message ako kung at as of this time, kung makakuha na ka mo test tapos hindi ka mo you don't want the result na basi 10 out of 20, so you're not convinced to have that score, so yeah, you could ask me to erase your score and you take a test again before the deadline, before today. You could take at least one retake of the test, of the test, summary test, because I put 2 points for this sa conversion and the host ID and network ID. So it takes time to solve the problem, so that's why I will have it 2 points, because my problem solving. So 2 points ang may binary to decimal conversion, at the same time my network ID at host ID. You could email me if you want to have the retake of the test 03 and I will erase your score. And that's it. I think we are okay. So we will end on this side. I think, any more questions before we end the lecture? My camera is, I think, it's not working. I don't know why. Any more
May schedule
questions?
pa sa test, sir, sa Sininga Week.
Tomorrow is already the last intake of test 03. But on Wednesday, I think I'll just give you some exercises on Wednesday. Maybe Wednesday we will not have a class on Wednesday afternoon. I'll just message you the module or the exercises that you're going to do, like subnetting, subnet mask, what we are doing here, determining the network ID, the host ID. So those are the exercises for Wednesday, so that you will have enough practice, because our end term exam is next week already. So if you find it difficult to convert subnetting this, identifying the network, the host ID, you could not do the project, because once you created the network, you need to find the number of hosts, the number of the network ID, and I will not give you one company that you're going to create a subnet mask, but only small mga ano lang, laboratory, mga amo lang na hindi ginta makadako na. Normally class C, we will do class C on your project. But on your project, I cannot assign yet the person on the project, because we are not done yet with the discussion on VLSM and other lecture. But tomorrow we will finish all lecture 3 and After that, we will move forward to VLSM, and hopefully we could finish. Hey, Louis Meister Campon, are you there? You need to retake your test because the score was really low. I don't want to have that score 4, 5 out of 20. So that's why I removed your previous take. So you need to retake, and if you want assistance, you need to ask your classmate also if you don't know how to solve the problem. And also please review before you take the test, because this test is taken once only. So if you want to retake, I will erase your score and you take it again. Okay. So any more questions regarding host ID and network ID?
None, sir.
Okay.
And sir,
Okay, sir.
Okay, please try to finish the test 03 today, and until tomorrow, I think, would be the deadline. So I'll give you enough time to make it good. Okay, goodbye.
thank you, sir.
Bye-bye.
Sige,
Sir.
sir.
Happy Teacher's Day, sir. Teacher's Day.
Go good, sir.
Okay,
sir.
Have a good Thursday.
happy.
Peter Thursday, that's sir.
Thank you. Wala ako kabalan na Teacher's Day song.